Hi, welcome to your lesson on dim sum of terms in an arithmetic sequence. As most of these topics are, this is a big concept, big idea in mathematics. Let's begin with a little story about this guy right here. This man is Carl Friedrich Gauss, one of the most famous mathematicians in the last millennium, let's say. There are the years of his life, and he is often called the Prince of Mathematicians, based on the contribution he's made to all kinds of mathematics, including number theory, algebra, statistics, analysis, differential geometry, electrostatics, astronomy, optics, and more. So he was very involved in science and mathematics, physics, and so on. There's a story about Gauss and his childhood, and the story goes like this. The famous mathematician Carl Gauss was a young man or a young boy at school. His teacher asked the class to add up the numbers from 1 to 100. The teacher expected this activity to keep the class quiet for some time, and so he was amazed when Gauss put up his hand and gave the answer, which is 5050, almost immediately. How did he do this so quickly? Well, he's famous mathematician for good reason. And notice here, his face, his image was on the 10 Deutschmark note back in Germany pre-Euro times. They used money called the Deutschmarks, and he's so famous he was on the 10 Deutschmark note. So how did he solve it so fast? Here's the sequence, and the goal was to add up these numbers from 1 to 100. He looked at it this way. You have all these numbers from 1 to 100. Let's say you put the first number and the last number together, 1 and 100. That makes 101. Let's say you put the second number and the second last number together, 2 plus 99. That also makes 101. This pattern continues. Let's say you put the third number together with the third last number, 3 plus 98 makes 101. Basically, you can pair off all the numbers and make the same sum every time, 101 every time for each pair. So he said, well, if there's all these pairs and they all make 101, how many pairs are there? Well, if the numbers go from 1 to 100, then there must be 50 pairs, right? Because you break those in half, there's 50 pairs. So basically, if you do 50 times 101, because each pair adds up to 101, then you'll have your answer for the sum of all those numbers. That's pretty smart. Good thinking, good noticing of patterns in this for sure. And from that, we can make this rule. This rule is the sum of n things in an arithmetic sequence is you find the sum by adding the first term u1 and the last term un. The last term will be un. So u1 plus un, which will be in this case 1 plus 100, which is 101. So the sum of the first and last, and you multiply that by n over 2. N representing the number of terms, in this case 100. So if you did 100 divided by 2, you would have 50. And again, that's like having 50 of these pairs of numbers. So there's our formula. So we're going to take some notes now. Back to the packet where you've been adding all the notes and formulas. It's a stapled 2-page packet, the one that has our arithmetic and geometric sequences on the front. So on the back of that front side, find the area that says arithmetic sequences and sum of the first n terms in a series. When you have a sequence and you're adding up the numbers in it, we call that a series. So find this part for arithmetic, and let's put the formula in there. So there's the formula one more time. And now we're going to use the formula just for 2 problems, and there is no assignment to follow this as well. So let's see if we can just solve 2 problems, and you'll get an idea of how to use this formula. So the example given here is the first 4 terms of an arithmetic sequence are 5, 8, 11, and 14. We can see this is arithmetic because every time you add 3, so the d value is 3. All right, and u1 is 5. So calculate the sum of the first 80 terms. So that would be kind of take a long time if you had to do that by hand, like 5 plus 8 plus 11 plus 14 plus 17 and so on. That would take a long time to do the first 80, but we can use the formula. Notice in the formula we need the first term, which we have is 5, and we need the last term, which is not 14 because this goes until forever, but we need the 80th term because we want this to go all the way to 80 terms. So you should begin by finding what the 80th term is because you need it to use this formula. You need the last term. So begin with this formula and see if you can get the 80th term first. What is the 80th term? All right, so if you used our basic arithmetic nth term formula, hopefully you got that the 80th term is 242. So now if you know this continued all the way to the 80th term, that term would be 242. So now that we know that, we can use this formula. So try using this formula and see what the sum of all these 80 terms would be. So here's how we would set it up. We'd write S of 80, which means the sum of the first 80 terms. Here's the first term, here's the last term, which is number 80, and then you do n over 2, because that would be 80 over 2, which means there's 40 pairs of numbers that have the same sum. And that is a total sum of 9,880. Okay, we're going to do one last problem. This is on the attached page, the page that has like the practice problems in different parts using each formula. So find arithmetic sequences and find the one question, this one, which is the sum of arithmetic sequences. So this time it says find the sum of this series. So here's this sequence of numbers. Is it arithmetic? Well, let's see. -3 to 1 goes up by 4. 1 to 5 goes up by 4. This goes up by 4. So it's arithmetic. We're going to use that same formula. Again, it's called a series because when we're taking the sum, we're adding up all the numbers, we call that a series. So first of all, in this one, you'll have to begin with this formula as well, because in this case, we don't know which term number this is. And we can't use the sum formula until we know how many terms there are in this sequence. So to find out which term this is, use this formula. Try it now. So hopefully you set it up like this. We have some mystery term in the future, so we're going to replace un with that term. And then we're going to plug in the first term, which is -3. The difference here was 4 every time, so 4 for that. And n is the unknown. We don't know how many terms bring us to this mystery term number, or which has a value of 81. So if you solve this, first I multiplied 4 through here and here, so 4n and -4. Then I'm going to combine the -4 and the -3 to make -7. And then move the 7 over there. 88 equals 4n. Divide by 4n. And you get 22. So the 22nd term is this one, which is 81. Has a value of 81. It's the 22nd term, or it is the term at position number 22. So now you can find the sum of this entire series. Try it now using our sum formula. Okay, hopefully you substituted things like this. You say the sum of the first 22 terms. Here's our first term. Here's our last term. And again, we know this is 22 terms. That's what we found here. 22 over 2. Multiply all that, and the answer was 858. Hope it all worked out for you. This formula is pretty easy to use, and let's leave it at that. There is no practice assignment that follows this. Good job.